This is the National Weather Service office in Wakeville, Virginia. We work closely with the forecasters here and at the National Weather Service office in Mount Holly, New Jersey as well to give you reliable information. Larry Brown is the senior forecaster here. He's working on the forecast, and in this part of the world, forecasting is never easy, especially when it comes to snow.
We always have this challenge of this rain-snow line or ice, depending on, that tends to bisect our region. So very often Norfolk in a kind of storm like this started off as snow, goes to rain, and was mostly a rain event, while further inland and north and west, it was mostly a snow event with maybe a little sleet mixing in. So it's always challenging, are we going to get, 1.5 feet of snow in parts of the area and mostly rain in other parts of the area.
NOAA is putting online 2 new supercomputers that will make life a bit easier for those of us who forecast the weather, and you can actually see the difference high-resolution models are already making.
I'll show you the difference between 2 models. This would be sort of our more standard model we've had for a long time, showing the wind over the Chesapeake Bay not being too much different than the land. And look at the difference between, here's a higher res model. You can see the difference, how much more wind it shows over the bay and the ocean, and how much more of a gradient there is between that and the land.
One of the reasons Congress finally gave NOAA the money for those badly needed computers is that our long-range weather models are not as good as what Europe has, and forecasters like me have been relying heavily on their ECM model for forecast from 2 to 10 days out. The new computers will bring improvements in the long-range NOAA model, called the GFS, but also improvements in NOAA's new high-resolution short-range model, which is getting rave reviews from me and my fellow forecasters. We're also behind Europe and Japan when it comes to weather satellites. We're still watching the equivalent of black and white TV with just a few channels, while Europe and Asia have an HD color set with plenty of channels. You're looking at some of the amazing imagery from Japan's new Himawari satellite. Both it and the European Meteo satellite can see many more wavelengths of light and can make almost true color images. In addition, Japan's satellite can send an image back every 2 minutes if needed. That too is about to change. In October, NASA will launch the much-awaited GOES-R weather satellite. You'll see high-resolution images from space that will amaze you. And during serious storm events, we'll get images every 30 seconds. And GOES-R will see lightning flashes as they happen. Currently, we only see cloud-to-ground strikes on radar. But 2 summers ago, I participated in a NOAA experiment in Oklahoma, and we evaluated how this new technology will improve warnings. Our conclusion? It will be revolutionary. With the growing population and the effects of climate change becoming more noticeable, accurate forecasts are a necessity. And with the faster computers and the new GOES-R satellite, this year will mark the beginning of 21st century weather forecasts.